Hello, everyone, and welcome to the final day of learning about Newton's laws of motion. Today, we're going to do the third and final law of motion, which I think kind of wraps everything up pretty nicely. So, without further ado, here we go. Newton's third law of motion, I have a picture of a rocket ship here, and we will kind of talk about why Newton's third law of motion is essential in kind of how things move in space. So let's take a look at Newton's third law of motion. It says, for every action, there is an equal and opposite reaction. And the key words here are really that for every action, equal and opposite reaction. And we're really talking about forces here, right? So if you have a force going in one direction, you always have an equal force going the other direction. Now, I don't know about you, but my kids and I have been watching quite a few movies recently, just because the weather's been kind of crap, and there's not a lot else to do. So, they're watching Big Hero 6, which is one of my favorite movies of all time, actually, and I'm hoping that they get around to bringing out a sequel sometime soon. But in the meantime, we've been watching it again, and there's one scene, it's not the ending, but it's towards the end. If you haven't watched the movie, I highly recommend you watch the movie first. Obviously, you can kind of skip this, but I will ruin it a little bit for you if you haven't seen it. So what's happening is Baymax and Hero. Baymax and Hero are going into. Well, they've gone through the portal. They're kind of in this alternate universe right now, and they've just saved this girl that was stuck in there, and they're now going to try and get out. Okay, I'll let this play out.
My thrusters are inoperable.
Just grab hold!
There is still a way I can get you both to safety. I cannot deactivate until you say you are satisfied with your care.
No, wait. What about...
You are my patient.
Baymax,
Your health is my only concern.
Stop! No, I'm gonna figure out...
Are you satisfied with your care?
No! There's gotta be another way. I'm not gonna leave you here. I'll think of something.
There is no time. Are you satisfied with your care?
Please, no. I can't lose you two.
Hero, I will always be with you.
I'm satisfied with my care.
Obviously, there's a very sad, like I said, almost ending. I'm not gonna lie, I shed a few tears when I watched that the first time, and my kids definitely did too. Um, but there's some kind of great bits in there physics wise. Just dealing with what we're dealing with. So first of all, they are in. I'm not going to call it weightless. I think there's kind of very low gravity situation here. The only way that they figure out that Baymax can get Hero out of this universe is to use his rocket fist to fire him towards the portal. And it works. So you can see in the background. Now you look at this bit, you'll also see Baymax flying or being pushed kind of into the abyss. He's going the opposite direction. And as horrible as it sounds, that's a perfect kind of explanation of Newton's third law of motion. For every action, in this case it was Baymax, his rocket fist pushing Hero towards the portal, there's an equal and opposite reaction. So the opposite reaction is Baymax being pushed back. And that's essentially what Newton's third law of motion is. So how does it work in rockets? Well, let's take a look. Oh, and I did this earlier and forgot to clear my work. Here we go. So we're looking at a rocket ship in space. And not going too far and discarded everything. There we go. So we're looking at a rocket ship in space. Firstly, lots of people think, oh, there's nothing in space. There is. There's matter out there. It's just because we're not in the Earth's atmosphere. Air is a lot thinner in outer space, but there's still matter out there. And rocket ships take advantage of this. Obviously, they have these rockets, and they are firing backwards here. Now, if you were right here, so there's a little person right there, obviously you would feel the intense heat, and that would be bad. But you would also feel this great force pushing on you from these rockets. So we're going to say there is a force being applied in this direction. And that makes sense. They're firing kind of a lot of gas that's been ignited, and it's being forced out this way. Okay, then Newton's third law says in this scenario there will be an equal and opposite reaction. So there will be an equal force, but in the opposite direction. And that's needed. That's needed because that's how the rocket is going to move. So I think this wraps up Newton's laws pretty nicely, actually. Newton's first law says an object at rest is going to stay at rest, or an object traveling at a constant velocity is going to stay at that velocity unless there's a force acted on it. So this rocket ship is taking advantage of that, says I need to move, or I need to move faster, I'm going to apply a force. Newton's second law says force equals mass times acceleration. Obviously we have a large rocket here, so we're going to need a big force to move it, which is why it has these larger rockets. It has 4 thrusters on there. So it needs a big force to accelerate in the opposite direction. And then the third law, again, it's taking advantage of. It says, okay, well, I'm going to push backwards, or kind of the opposite direction I want to go. If I push backwards, it's going to propel me forwards because of Newton's third law. And that's really it in a nutshell. So fairly straightforward. And again, lots of people know this. This isn't, I was going to say this isn't rocket science. This isn't something that is crazy to us when we think about this kind of thing. We know this. But back in Sir Isaac Newton's day, it was a bit crazy. No one was thinking like this. All right, here we go. There is no exit ticket for today because there's a little bit of extra work I'm going to have you do on the lab stations. So go back to your lab station sheet, and you are going to complete station 12 through 15. So if I go down here, scroll all the way down, hopefully you've done all these. If not, take the time, finish those up. And let's just scroll right down. Station number 12, you may not have a balloon, that's fine, there's a video, you can watch that. This one's kind of fun to do. Just need a couple of sheets of paper, and you don't need to run too far. So pay attention to this part. Okay, next one. No one's going to have a Newton's cradle, so just use these two interactives. If you have a Newton's cradle, I will be very impressed, by the way. And then station 15. Oh, did we skip one? No. Okay, station 15. Again, only do this if someone at home lets you do that. Fill in your data, just for these 4. What I want you to do when you're doing your observations, relate them to Newton's third law. Okay, they can be short and sweet observations, but I want quality over quantity. So make sure that any observations are talking about Newton's third law. Right, then just go through the post-lab questions. There's 5 of them. Again, quality over quantity. You don't have much space here. Type in, what did you observe about Newton's first law of motion, so the labs you did? What did they all have in common? The second law of motion labs, what did they have in common? Third law of motion, what did they have in common? What did you see? This is pretty self-explanatory. Just answer, okay, what force in station number 6, so you'll need to go up, look at what that station was. That's the one we had the glass and the paper and then the coin on top. So what force made it drop in there? This one, question number 4, if you didn't do it, just have a guess. What would make 2 eggs spin differently if one is raw and one is cooked? And then last part, restate Newton's laws in your own words or give me an example of them in real life. And that's it. Once you are done, I believe you can submit it. So make sure you've filled out your table all the way down to number 15, done the post-lab questions, and you should be able to submit it. So it'll end up in my submissions box. All right. As always, if you have any questions, drop me an email or send me a message through Schoology. Otherwise, I hope you have a great day, and I will kind of check in tomorrow on Friday.